right. Well, thank you so much for joining us today. My name is Jeff Nepper, and I am pleased to walk you through the 5 steps to building a proper analytics foundation in our webinar. A couple quick housekeeping items as we go through the presentation. Please use the Q&A box for any questions that you'd like answered, and we'll save those for the end of the webinar. All right, well, let's get started. So I can't thank you enough for joining us today. And at Flow Software, our focus is helping you to unify and access your OT and your IT siloed data from a single point. We know that in order to really supercharge your analytics, to make better decisions, what you need is information that you can trust. So our goal today is to walk you through the 5 things that you should consider when you're trying to build out your own analytics foundation. And to do that, we have to first understand really what is analytics? What is the goal of what I want to do? 4 different things that we should consider when we talk about analytics. The first, and I think probably the most basic or most common, is the descriptive analytics. And that is what happened. So we're trying to answer and identify that question of just what has happened historically. So a lot of times we might look at a trend inside of a historian. We might look at a table of data and understand in the last hour, we've had these different values. And then the next piece of the analytics continuum is this conversation around why did that happen? And so that's our diagnostic analytics. So we build on top of what happened, and then we look for causation or perhaps correlation. We do this by often adding a second data source. So I've got my historic records, but now I want to understand and overlay something else on top of that for contextualization. Next, we look to the predictive piece of analytics. So I know what happened. I know why it happened. Now I'm looking for input on what should be done. So this, or what is likely to happen, rather. And this comes into play on typically, as we start to forecast things like maintenance or projections of uptime or downtime, a lot of times this can be basic. It could actually be very elementary and just be some statistical type of modeling techniques or some basic predictions or forecasting. And then finally, the 4th piece of the analytics continuum, and this is really what we might consider to be that holy grail of analytics, what everybody is hoping to chase after in the future, but really no one's there yet in mass, and that's prescriptive. And so not only is this what should be done, but if we really frame it, it's more about based on the priorities of my organization, this is the action that should be taken that is most likely to achieve the organizational goal's primary outcome. So maybe it means we should reduce the speed of a piece of equipment so that we maintain its uptime, knowing that in 2.5 weeks we have scheduled downtime at our plant. So the action is based on the overarching goal of the organization. This is where we really start coming into deep machine learning or AI. All right, so if that's our analytics foundation, we have to understand that the foundation of this analytics continuum is really descriptive. That's what everything else is going to build on top of. And not only is that the foundation, but right now, if we look at where the value is in most operations, it's not in prescriptive, it's not in predictive. There's still so much work that can be done and so much value that can be captured by getting that descriptive and diagnostic foundation firmly planted. And so to that end, I would ask you to consider in your own organization, what is the currency that you're actually trading in? What I mean by that is, if analytics is important to you, what is the driving factor of not just the analytics that you want to perform, but all of these systems, all of these tools that you have in your organization? What's ultimately the currency that we're trading in? It's not the widgets that we make. It's not the process. At the end of the day, our currency is simply information. The goal of what we're doing is to get information out of all of this so that we can drive our process, so that the outcome is making more widgets or increasing our efficiencies, being more sustainable, growing as an operation in general. And so with information as the goal, let's look at what that typically might look like in order to get there. So if we think of a BI tool, for example, let's just say Power BI. If I want to produce usable information in Power BI, what's the integration steps involved with that? Well, I have to go to my descriptive, right? My historian, grab some history. I have to go to maybe more of my diagnostic and grab something out of my MES system. And then I have to standardize that data, normalize it, if you will, in the BI tool. Once I get an actual calculation, so I'm aggregating data from two different sources, I'm creating a KPI. Now I need to share that, or I have to distribute that inside of my organization. That means that I'm going to build an email report and also then do a configuration inside of one of my messaging apps like Teams. All right, that's a good bit of work. And I've done that work to get 1, 2, 3 pieces of information for someone. Well, now what happens when there's another piece of information that I want? And this time maybe it's in my enterprise asset management solution. Well, I have reached back down to my historian, grab some data out of the SCADA system, again, create a calculation or some type of an output that I'm pushing out into email. And this work continues. Every time there's something else that I need to access or something else I want to build upon, I am reaching across my stack and I'm doing all of this integration. There's a couple big problems that we're facing in order to get to the information that is the currency, the value of our organization. The first problem is that the underlying data sources, all of these systems that are siloed, independent of one another, well, frankly, they just lack standardization. So standardization meaning everything from the format of how the data is presented to the structure of that data silo. And then the second problem, as you saw, when I do the work inside of one of the analytic tools like Power BI, or I do the work and create the integration, I've literally stranded that work and orphaned it inside of that data consumer. So I'm not doing anything to build upon the work that I'm doing. So integration costs go through the roof. My time to value is extremely, extremely slow. There's got to be a better way to do this. And so if we follow that unified hub spoke type of model and say, how do I just take everything that's in my organization and connect it to one central platform so that when I do this standardization, when I do this integration work, I don't have to live in it over and over and over again. And that's the data analytics foundation that we want to help you create. And so today we're going to tell you from the Flow software perspective, what is the secrets that we've learned so that if you wanted to try to build this yourself, you'd be able to do so successfully. And so for Flow software, this journey actually started back in 2015. The goal was to give all of the customers that the system integration business that Flow grew out of, all of the customers that they served, they wanted to give them more confidence in their decision making. And so in order to be able to do that, they had to essentially help the customer understand the operational pain points that they are experiencing by giving them easy to digest information so they could solve those pain points. And that's really what Flow was born out of. Today, there's offices in Austin, Texas, as well as in Johannesburg, South Africa, and Flow goes to market through integration partners. That's both sales and implementation. So brands around the world that have been taking advantage of this system integration business that Flow came out of did a ton of work in food and beverage, which means all of the major food and beverage companies that you would expect at very high scale have taken advantage of Flow, as well as general manufacturers, aggregate companies, mining companies, etc. But there's 5 things that I've promised to reveal of the secret sauce, if you will, to building your own analytics foundation. Let's dive into that. The 5 components that you're going to want to make sure you address when you build your analytics model begins with this concept of a unified information model. Then we connect the data sources, these siloed databases, to that model. We build out calculations and transformations of those siloed data points. We visualize it, and then we bridge that data out. Those are the 5 steps that you want to make sure that you cover. Let's dive into each of them with some more detail. So we'll begin with model. Model seems like it would be pretty straightforward. We talk about modeling a lot. And often when we talk about modeling, we're talking about hierarchy. We're talking about how you take parent and children assets and relate them to one another. So ultimately, it becomes a group of tags that represent a piece of equipment, and where inside of the process does that equipment live, and what's that structure. But in an analytics hub, the model needs to have more than just hierarchy. So if we look at this example from a Flow screenshot, and we start at the very top of the model, what you'll see is that we have a factory represented. And inside of that factory, we have different areas of our process. We have utilities, we have our raw materials, we have prep, we have packaging. Now we've expanded packaging and we've come into a line. And inside of the line, there's a filler. And as we look inside of the filler, we have a production, a rejection, we have a utility usage category, and then we have a volume produced category. But notice what's not being shown as we expand volume produced. What you're not seeing is just a list of tags, because inside of a unified information model, there needs to be information. And what is information if it's not contextualized raw data? And so in the information model that you want to build, you need to establish a sort of data governance. And this is from the top down. When you as an organization decide, when we talk about our assets, when we talk about our process, it's not just a matter of understanding what tags or what IO we have. What we really need to establish is, what is the information that we want to collect? And in this case, if you look at volume produced, which is probably being driven off just a single tag, look at all of the different KPIs that we've decided that we are going to collect. We have an hourly KPI, we have a shift to date, a shift, a daily, a month to date, a week to date, a weekly, and a monthly KPI. Now there's something missing that we have to create in order to have these KPIs. Can you figure it out? What's the one thing that's always missing from a tag? Well, we have raw data, but we don't have a concept of time, meaning we don't have a concept of our shift calendars or our production calendar or our finance calendar to add contextualization to that totalizer tag. And that's really where the power of an information model comes into play. Because not only do I get to say, here are my tags, and here's the assets that my tags represent, and here's the hierarchy of those assets. And within that hierarchy, here's the information I want to capture. But now we get to say, here is the calendars and the shifts and the patterns that I need to overlay on that information in order to be able to speak about those KPIs universally. So think about this. If you had 2 different sites, you might have a day represented in completely different time brackets. One day could be 12 a.m. to 12 a.m. Another day could be when my first shift starts, and that might run from 6 a.m. until the end of second shift at 8 p.m. By adding the information model to give it this concept of time, now all of a sudden, for every single site, every part of my operation, I can create standardization around these KPIs. Once I've done that, once I've created my information model, the second step to building a proper analytics foundation is simply plugging in the sources. And so if you think about your model that you've created this standard on the enterprise side, and now you've, with this data governance in mind, you've templatized it and you've pushed it down to your operations. And now you say to your operation team, connect the right pieces of your process to this model. So what do? They look within their operation and they say, back to our example of the juice factory. I have, for my utility usage, I've got a OPC server that is telling me my current water usage. So I'm not historizing it, maybe because it was difficult to hook that up to the historian for whatever reason. Maybe it was I didn't have the tag license to do it. So I'm going to connect that real-time sensor now into the model. It's okay that it's not historized. I can grab it in real time. Likewise, I might reach right down to a PLC and grab that information. But I certainly will connect historical sources to my model. And so this could be some of the industry's most popular NoSQL solutions like Canary, OSI. It could be some cloud-based solutions. It could be SQL-based historical solutions, Influx or Timescale. Once I've connected those, then I've got the grab bag, if you will, of my relational or transactional data sources. So think of all of the other solutions inside of my operation, my MES systems, LIM systems, ERP solutions. It could be something as simple as a Waybridge or an alarm database, or it could be something that's maybe a bit more advanced, Azure, AWS databases. I can connect PostgreSQL, Oracle, MySQL, MS SQL, Cloud. Whatever it is that is transactional or relational, I need to be able to go grab it and bring it into my model. And then finally, the fourth and most overlooked when you build your analytics solution is how am I going to go after the less sophisticated things? So the clipboards and the spreadsheets. Right now, I can guarantee you somewhere somebody is manually writing down values or they're entering them into a spreadsheet. How do we get that into our analytics hub so that everything downstream gets to take advantage of it? And that's typically three different categories of data. It's actual data capture, so values that otherwise would not get entered. It's data corrections. Hey, I know the historian says this value, but I had a sensor issue. It should be this. How do I update a value and version it? And then finally, how do I categorize values? We were down for 33 minutes. What was the cost? How do I code that? Once we've gone through all of the connections, now we are ready to transform and we're ready to store. So the third step of our journey. This is key because up until this point, everything is still silent. It's plugged into our model, but it doesn't have contextualization. There's no knowledge of the historian isn't really aware of what's going on in the MES system. So we want to be able to use the transform feature of our analytics hub so that I can reach out to something like a historian tag. And if we think of a historian tag, right, it's always really easy to understand time series. We've got this nice timeline and there's value changes. And with each value change, there's an associated timestamp. Well, the beauty of a proper analytics hub is that I can do that exact same process with a SQL query. So I can look to a tag inside of SQL and I can say, hey, I want to force point normalization across this SQL query and this historian tag so that when I look at them together, I can actually perform row-based calculations with zero data loss. And the output of that is what we would call a calculated tag. And there's a lot of different reasons to use calculated tags. It could just be something as simple as saying, hey, my SQL database is telling me when we were or were not running, and I only want to count data inside of the historian in this calculation based on state awareness. Or it might be just flip it around. I might have quality scores inside the historian, and I want to filter out data based on quality. Or maybe if it's outside of band, I only want to totalize, for instance, when we're active. So many different use cases to these calculated tags. And then once we've done all of this, then we can actually take data inside of the tags or the calculated tags. Now, in this example, I'm only showing 2 input tags, but there's not a limit to the number of input tags that I would reach out to. So this could be data in 2 different databases, 3, 4, 5, a dozen. There's some very complex use cases here for an analytics hub to reach to many different underlying data sources. But ultimately, what am I trying to derive from all of this is I'm probably trying to understand something around events. I want to get some contextualization of were we doing this or were we not doing this? And so I need to create periods, and then I need to assign attributes and associate them to those periods. Now, it would be helpful inside of your analytics hub that you build out to capture this information. In Flow, we capture that and call it an event. Once you've done that, now all of a sudden you've got things like downtime that you're tracking, different batches or process steps, state of machines. So it doesn't have to be overly complicated. It could be, or it could be very simple. Okay? We were making this product. So now with this calculation tag, contextualize, point normalize, multiple sources having been combined, I can look across it and I can do 2 different things. I can say I've got all of these data points that I have calculated. I can begin to assign time periods to that data. So we've done point normalization. Think of this as period normalization. So I can say, let's take this stream of data and slice it into hours, or slice it into shifts or days or weeks. Using that information model that I've established, I have my periods or my patterns that I'm looking for. And once I've created these new data points using aggregation, period-based calculations, I'm able to then store those as measures. And so it's a KPI measure. So it would be helpful not just to store events in the attributes, but also to roll up or to slice that data stream and aggregate up into KPIs. Examples of how this gets used, it could be things like equipment efficiency, hourly totals of utility usage, costing, revenue, production counts. Something that really becomes helpful is projections or forecast. So using things like linear regression or exponential regression, I can say it's likely that I am going to end here by end of shift. Or based on historical data, I can say that if we continue in this path, we will produce this many at this point in time. Now, there's extra bonus to this because not only am I able to create KPIs based on time slices, but I could also take those events and the context around those event periods, and I could create secondary KPIs based on aggregations during event period and store those as well. Make sure that you caught that part of store. So not only are you doing the transformations, but then you're storing not the raw material, not the raw data. You're not duplicating the databases that are underneath. You're only storing the outputs, the events, the attributes, and those KPI measures. Very important that you set it up that way so that you can be extremely efficient and not have to sit there and run the process constantly on every future query. Okay, so we've moved through transform and store. Let's talk about how we share this information now with people in our organization. We share information through visualization. Visualization is important, and so that we can easily put dashboard reports in front of people. This could be just connecting to visualization that you already use, but if you don't have a great dashboard tool, you're going to definitely want to build one. Best practices, we believe, is to make sure that that is an HTML-based dashboard. That way it can be embedded in other products, and it would be really easy to in turn embed other products inside of your dashboard. So HTML5 is always the most flexible way to serve information to people. That means whether it's on a laptop or an iPhone, it just works. This could look like trend charts. It could look like KPIs in the form of value boxes, as you see across the top. It might be a bar chart or a pie chart or donut gauge. There's a lot of different flexibility in how you would want to create your visualizations. In Flow, one of the ways that we visualize is by using things like XY scatter plots, multi-band trends, as well as heat maps and data tables. Data tables, which help give you not just visual information, but also give you an input. So remember back to the way that we connect. When we build an analytics hub, we want to have manual data entry. Why not just build that manual data entry into one of your reports? So perhaps you could have a field that just says weekly production goal or daily volume. Whatever that is, you can add that into your dashboards. And then finally, I think I mentioned earlier, 2 other use cases. If your analytics hub, when you're talking about these measurements and KPIs, one of them being projection values. So here you can see a way that we've actually shown, it's going to be most clear on the bottom chart. You can see that there's 2 different lines projected past the current point. The current point is the red bar halfway across that bottom graph. We can see looking forward, we are likely on Tuesday to arrive at 1 million and maybe 10,395 units, even though that right now we're at 6.9 million units. And based on our linear regression, it looks like we are going to arrive just above our production goal. And then finally, that data entry piece comes back in our ability to code things like downtime and then visualize the causation of that downtime. Every great system needs visualization, whether that's built on top of the system or whether it's empowering other visualization tools that you already use. And so if there are other visualization tools that you're already using, you want to make sure that your hub has the ability to bridge out. So this is really the key differentiator between most products that are out in the market today. And the number one question that I get the most at Flow has to do with, well, how is Flow different than this analytics tool or this analytics tool? And the very first thing I would recommend if you're evaluating what might be an analytics tool is you ask yourself, back to the original problem, if I do work inside of that tool, is it orphaned inside of that tool, or can I pull that work out and apply it to other analytics tools? That's the key here, is that what we want to do is we want to create a bridge. So when I build these calculations, when I do this standardization and point normalization, when I create events and store them, when I create KPIs and store them in the attributes of those, how do I serve that back to the underlying data sources? How do I feed that back to my relational and transactional data sources? How do I feed it back to my historians? How do I feed it in real time back to an MQTT broker? And then how do I feed it out through things like messaging apps, events, alerts, How do I update my team on progress? How do I feed it up if I want to tier my analytics hub? So perhaps I've been working on site, and now I want to take these events and KPIs and tier them up to a second enterprise tier of my analytics hub. And how do I tier them out to a single REST API? And this is really the secret to a successful analytics hub. No matter what your role is, maybe you spend most of your time on the OT side, or maybe you're on the IT side and you're joining us today from an analytics team. I want us all to wear our IT hats here. I want us all to wear our enterprise hats. There's a serious problem right now. And that problem is that in order to connect to all of these underlying sources, I have to reach out and know how to connect, and I have to have licensing to connect to all of these different siloed databases if I want to feed them into, say, a data lake. What we want to create in our analytics hub is a single endpoint that both unifies all of our siloed sources, has a standardization in the model so that all of our naming, all of our data governance is unified, and then gives us one access point to all of it. And that's exactly what this REST API is designed to do. So if you created a single API that was able to read through your model, understand the underlying connected sources, read the transformations and this data that's stored in that database. Now in Flow, that's stored in a SQL database, but the API gives you access to it. And bridge all of that out to other machine learning and AI platforms, maybe something to like Seek. So instead of just doing all of the work in Seek, I could do 80% of the work, prep work in advance, and just feed that work to Seek. And at the exact same time, take that same prepared work and feed it to Power BI, feed it to Tableau, feed it back out to my SCADA system so that I have a KPI in front of my operator that tells them the new average cost per unit. Everything from the attributes to the events that get stored to the measures that get stored, you need to be able to serve that out via that API. So it's not just what you store, but it's also what can you pass through. Through that same API, I should be able to query the underlying tags in the data sources. Whether that's a historian, whether that's a SQL database, I can query those points through this same API. Additionally, you want to make sure that the calculations that you're running, that you can pass that through in real time. So those calculations have been point normalized. Now, in line, in process, I can grab those calculations through that API as well. It's a lot of work, but if you build it right from the beginning, you will have all of that value downstream. Now, here's the good news. You don't have to build it all yourself. That's what Flow's been doing since 2015. So we want to show you the secret to our success. These are the 5 things: model, connect, transform, visualize, and bridge, that if you said, hey, I want to build this, this is how we would tell you to build it. The beauty of using something that's already been built like Flow is that we don't want to limit your success just to our platform. So everything that's been built has been built so that you can do it with no to little code, and that the work that you put in can get transferred right back out. So from the IT, I asked you to put your IT hat on. Think of this as the greatest tool to enable your data lake that you can possibly imagine, because no longer do you just have to throw everything into the data lake and then try to figure out how to contextualize it. We're going to take 80% of that contextualization work and do it right there at Flow, and so that your data lake takes advantage of it, and Power BI takes advantage of it. Your machine learning tools take advantage of it. So it's all about centralizing that work into one spot so that everything in your operation gets to benefit. So if you wanted to get started with Flow, I'd love to let you know how. Typically, what this looks like is a proof of concept. A lot of customers start with a very small Flow license, and that is an entry level as low as $5,000 for a year subscription to get started with Flow. We'd love to understand, if you wanted to get started today, how would you benefit tomorrow if you had this tool? What are a couple of KPIs, for instance, that you don't have access to right now that would be transformational for you? It could be as simple as, I need my executive team to understand what a widget cost at the end of the day. Or for sustainability, we need to understand what we're using in water and in energy to produce 1,000 units. It could be, I need my operators to have a better understanding of where they're going to be based on their current run rate. It might be, I need to know that at the end of the month, if we were 11% inoperable, that we were not operating because of these 3 main reasons. So once we define the things you want to measure, then we want to work with you to help establish those, in real business problems, those objectives. Because once we add value and identify value, then we add value, would be a better way to say it. So we want to define the KPIs. We want to highlight how this solves a business problem. We want to associate a value to solving that problem. And now all of a sudden, you've got a real ROI. We'd love to prove that value with you. And I would absolutely love to have you reach out to me directly. You can email me at jeff.nepper@flow-software.com. All right, let's take some of the questions that have come in before we wrap up for today. All right, first question, is there a SaaS model, subscription model, or is it perpetual? So Flow operates on either a perpetual business model, so you can buy a one-time license, or you can do subscription. Flow can be hosted in a cloud environment. You could put it on-prem. You could host it in your own private or public cloud environments. Flow Software ourselves, we do not operate a SaaS business model. All right, next question. A question around KPI packages. Okay, so KPIs, how do you calculate how many KPIs that you would need for a Flow system? Our experience has been that you can usually look to your historian, and that'll give you a bit of a benchmark for a site of how many KPIs you might expect. So if you keep a rule of around 10 to 15% of your historical tags, that typically is about the number of KPIs that you would need. Flow starts at 1,000 KPIs in its smallest package, and you can add 100 KPI license packages to that 1,000. So if you needed, say, 1,200 KPIs, we give you a methodology to do that. What other questions? Experience. Yeah, so question about the experience in the food and bev. So as I mentioned, Flow started from a system integration background, and the men and women that were those system integrators came out of the brewery worlds, and as a result of that, did a lot of work with AB InBev and Coca-Cola. And so AB InBev and Coca-Cola, between the two, are running very large enterprise systems that are have both sites and corporate tiers of Flow. And so that would be 30 or 40 different breweries or bottling plants, all with their individual shifts and schedules, all with a standardized information model, all using those KPIs both at site to run more efficiently, as well as tiering that information up to enterprise. All right, and last question. and then we'll wrap it. Is there a free download available? Yes, there is. Great question. In fact, you can get a fully licensed version of Flow that you can run in trial mode by going to flow-software.com, and you'll just see it in the top right-hand corner. The Try Flow button will get you started on that download. All that we ask for is an email address and a little bit of information about your operation. No credit cards or anything like that necessary. All right, well, I can't thank you enough for attending today. Again, we'd love to help you plan how you can be successful with building the proper enterprise analytics foundation and hub. Thank you for your attention. We'll talk soon.